All right, we're in geometry. We are on lesson 5-4. Today's date is January 25th. Please put that on your papers now. Make sure your name is on your notes. We are doing our first introduction to trigonometry. So trigonometry is this really fun guy with right triangles. So before we move on too fast, let's make sure that we have the correct vocabulary. We have participation cards out already. Let me make sure that I have my class craft ready to go as well. All right, hypotenuse. Who wants to define hypotenuse? Quiet raised hand. Lorea. There it is. Longest length. L-E-N-G-T-H. Mr. Sindel can spell. Yeah, so if I'm looking at the 90-degree angle, it's always going to be the opposite of the 90-degree angle. You always go across the angle from 90 degrees. That is going to be the hypotenuse. And you can just say HYP, just abbreviate. That's the hypotenuse. All right, thank you, Laura. And our new system, so we haven't done this before, I started this yesterday, is our marbles. So for every single person that participates of their own free will, it's one marble, and if you guys are positive and hardworking, it's a handful of marbles. All right, so it's XP and marbles. Let's do this. So opposite. Who wants to define opposite? Only one person knows opposite. All right, go for it, Ellery.
It's the it's the vertical leg of a right triangle.
Vertical leg. So the one that always goes straight up and down?
Yeah.
You're close, but that's still not quite right. I still give you XP though. And that's still a marble. Anyone else want to take a shot at it? I'm glad I'm defining this. This is the angle, or sorry, it's the length, L-E-N-G-T-H, length farthest from angle. The length farthest from the angle. So if this is the angle that I'm talking about, notice that there's this little mark in the bottom left. Then the opposite, well, the one that's farthest away is this length right over here. So if I'm talking about this angle, this is the opposite. So label that OPP, and then we don't have to actually write out the whole word, just opposite. All right, who wants to take a shot at adjacent? We have defined adjacent before with adjacent angles. Adjacent angles. Anyone want to take a shot? Someone that still doesn't have their card in? Then we open it up to people that have their cards in. All right, Ellery, go for it again.
It's adjacent or next to the angle.
Next to, yeah, that was the key word. Next to the angle. Thank you, Ellery. That's 50 XP. And another marble. All right, so next to the angle, and if you don't like that full definition, you can just say it's a neighbor. That's a synonym. So if this is the angle that I'm talking about, again, because it has the little mark here, the closest angle that is not the hypotenuse is this one on the bottom, and I'm going to call that one ADJ, adjacent. I'm just abbreviating there. So adjacent is the closest angle. You get arrows for each of them. Are there any questions thus far? Because we're going to have to be applying these right now. No questions, no questions. Let's move on to example 1. So now I'm talking about the angle right here and the angle right here. Those are the two ones with marks. So we need to label these from the perspective of the angle using these three words: hypotenuse, opposite, and adjacent. So from this perspective, can anyone give me one of those three? Someone that still has their card first? I only see one hand. Two hands. All right, India.
Opposite.
Which one is opposite?
Not the right angle, but the
Which leg? So if I guess I can label this A, B, C. Which segment are you talking about? A, C, B, C, B. BC is opposite?
Yes.
Close, but not quite. You still get your points for trying, though. So opposite, again, is the farthest thing away from the angle. If I look at my diagram, it's the farthest away from the angle. So opposite, the farthest thing away from the angle is this leg over here. So this is going to be opposite. Let's all label that in our notes. This is going to be opposite. It's the farthest thing away from that angle of reference. I changed the angle of reference now. The angle is now on the top instead of the bottom. So I was trying to trick us. You can still hand in your card, India. Anyone else? I need a hypotenuse and I need an adjacent. Only one volunteer. 2 volunteers. 3 volunteers. 4 volunteers. Leo. That's the 90-degree angle. So which one are you going to give us? C to A is? It is the hypotenuse. Thank you, Leo. You can turn in your card. All right, and therefore the last one is easy points. Who's going to do this one? Chewy?
So the adjacent AB?
That is adjacent. That's the next close, or CB. You said it, I think BC or CB is fine. Yeah, so it's right next to that angle. Thank you, Chewy. All right, now I have a new triangle. My angle is in the bottom right here. Who wants to label this one? I'm going to go ahead and call this A, B, and C, so we can talk about this easier. Who still has their card that wants to participate? Nice, we got 2 people. Beverly, you've been waiting patiently. It is indeed the opposite, because it is the farthest away from our angle A. Thank you, Beverly. You can turn in your participation card. All right. Another angle, another side length, sorry. Only one person knows it. That's not good. One person with their card knows it. All right, Colby, go for it. AB is the adjacent. Thank you, Colby. You can turn in your card. And finally, easy XP, easy participation card. Emily? Hypotenuse. Thank you. You can turn in your card. All right, so now we're going to use this knowledge to actually learn some trigonometry. So we're going to go ahead and call these things, this is how you write it in notation, but it's actually called sine. Write S-I-N-E above sine. If you pronounce this as sin, then people might laugh at you. I will try not to laugh at you, but it is pronounced sine. This is pronounced sine of theta. This angle right here, this we've seen before for angles, this is called theta, T-H-E-T-A, theta. So I read this, sine of theta. Sine of theta is equal to, and it's going to be opposite over hypotenuse. Opposite divided by hypotenuse. All it is a fraction. This comes from similar triangles. We just did our unit on similar triangles, so really we're just saying as long as you have this angle here and this angle here, all of those triangles are going to be similar. They all have this ratio of opposite to hypotenuse. All right, cosine. Cosine is going to be adjacent over hypotenuse. And yes, because these are starred, these need to be in your summary in some form or another. They don't have to be written out like this. You can just say sine is equal to OPP over HYP. And finally, tangent is going to be opposite over adjacent. So when I ask for a sine of an angle, you are going to give me a fraction. They're always fractions. Even if the bottom, the denominator, the hypotenuse, or the adjacent is 1, it's always going to be a fraction. And this brings me to one of my favorite and most famous mnemonic devices, the memory tricks of all time. Miss Aston, do you remember what it is? SOHCAHTOA. It is SOHCAHTOA. She still remembers it. The mnemonic device. Here it goes. Write it down. So, ka, toa. It sounds like maybe a Native American name, I'm not sure, but SOHCAHTOA. You will be best friends with SOHCAHTOA for the rest of the year. Whenever you're doing trigonometry, you will think of SOHCAHTOA. Why does SOHCAHTOA help us? Is there a quiet raised hand? Do you see some similarity between the definitions that I just gave you? Bless you. Some relationship between this mnemonic device and these definitions up here. Does someone see it that still has their card? What's the relationship? Do we see the connection? Why is this helpful to remember? Lorea, do you still have your card? Oh, sorry. Martine, do you have your card?
Yeah.
All right, what is it?
So it's the first letter of each one of the things.
So S goes with S, and what about O and H?
Opposite and hypotenuse.
So it's S sine is equal to opposite over hypotenuse. Exactly, Martine. Thank you. You can turn in your card. All right, remember SOHCAHTOA. If you can't remember all these definitions, SOHCAHTOA will help you remember. All right, so let's try to apply that knowledge. Okay, I chose my theta, my angle of reference, to be up here in the top right. So what is the fraction of sine? What fraction am I going to be given? All you're doing is using the definitions right here. You can tell me one number over another number. Which number over which number? I'm looking for someone that still hasn't turned in their card. Jaden, you still have your card?
Yes.
All right, go for it. Let's do it.
So I had 8
8
over 17.
over 17. So you're saying 8 is the opposite and 17 is the hypotenuse? Opposite over hypotenuse?
Correct.
There's a slight error. See if you can catch it.
It is. So it's 8 over 15.
No, you had the hypotenuse correct. Hypotenuse is 17, so it is over 17. But what
Oh,
over
so
17?
15 over 17?
Why is it 15 over 17?
I don't know.
Why is 15 the
I'm just
opposite?
going by this picture right here.
Yeah, so that picture was with this
Oh.
angle of reference, though. Now we're doing our angle of reference up there. I keep switching it back and forth. Keep you on your toes. So what is it? Why is 15 opposite?
Because it's across from that.
It is across. That's what I'm looking for. Thank you, Jaden. You can turn in your card. All right. Cosine. Someone that still has their card. Cheyenne. It is indeed 8 over 17. Thank you, Cheyenne. You can turn in your participation card. And finally, tangent is what? Go for it, Etsuri. It is indeed 15 over 8. Thank you, Etsuri. It is 15 over 8. All right, we're going to the back side. Does anyone need me to slow down to write down stuff? And we're going to the back. All right, now we're doing harder problems where we're actually using that knowledge to find missing side lengths. There are 2 homework assignments tonight. If you have paper homework, that means you have 2 papers. If you're doing Khan Academy, you have 2 assignments on Khan Academy. This is the second assignment. The first assignment all looks like example 1. These are harder, so I gave you more examples. Here we go. I need to find this missing side length, AB. And I'm going to round to the nearest hundredth. How am I going to do that? Well, I'm going to start by writing the trig statement. First of all, if I'm looking for these 2 side lengths with this angle of reference, which trig function am I going to be using? And is it sine, cosine, or tangent? You have a 33% chance of getting it right if you randomly guess, but we know this. I'm looking for someone that still has their card. This length over this hypotenuse. I already gave away too much. That's the hypotenuse. You need to be asking yourself, is this adjacent or is this opposite? And then after that, which trig function am I going to be using? There's basically 2 or 3 people that still hasn't participated yet. I know who some of them are. I might have to cold call on you. If I cold call you, don't get a marble, though. You going for it, Aurelio? Close. Cosine would have been this one down here. Cosine. You still can get your participation card in, and you get a marble. Oh yeah, you are on Class Dojo. Anyone else want to take a guess? Caroline, do you still have your card?
Yeah.
All right, go for it.
Sorry.
It is indeed sine, because opposite of the angle over hypotenuse. So, I'm looking at this. Opposite over hypotenuse, we're dealing with so of the SOHCAHTOA, so it's going to be sine. So write down sine in your notes, everyone. Thank you, Caroline. That was the wrong, okay. You got a little bit of extra, sorry about that. All right, so sine of the angle. Well, now instead of saying theta, I actually have an angle. It's sine of 27. Write it down. Sine of the angle, sine of 27 is equal to the fraction. Is there someone out there that can help me with the fraction? There's still at least 1 person out there that has their participation card. I think there's 2. I think it's Oscar and Brian. Is there anyone else that still has their participation card? All right, Oscar. Find the fraction of sine. Is it 6.8 over x, or is it x over 6.8? Oh, hold on. You want to give it to Brian?
Sure, 6.8
Over question mark or x, whatever, unknown? You are correct. It is 6.8 over whatever. It is 6.8 over x. All right. From there, I need to solve. And here's a cool little trick. That's the first and hardest step, is to set up your problem using the trig statement. From there, I need to solve. And here is your cool trick. Make this thing divided by 1. Write it down in your notes. Maybe I should do this in a different color because this is extra on the problem. Make this divided by 1 so I have one fraction equal to another fraction. One of the cool tricks with fractions is I can switch diagonals. I'm just allowed to change places of the x and the sine of 27. By changing places, this now turns into the problem x is equal to 6.8 is still on the top, but now sine of 27 is on the bottom. Sine of 27. You can only use this trick if there are two fractions and you can only switch the diagonals. It's really helpful when x is in the bottom. Helpful, x is on the bottom. I'm going to write this in the notes. You don't have to write this down. This was in the bottom. Bottom needs to be on top. From here, I just calculate, and you will need calculators, so I'll do this for us. Let's pull up my calculator. So if you have one of these calculators on your Macs, you're first going to do 6.8. 6.8. That's going to be divided by sine of 27. Divided by, and I'm going to do 27. Sine of 27 is 0.45, and then when I hit equals, it's doing 6.8 divided by this number, which is 14.978. Is there a volunteer out there? One last volunteer, I think it's on you, Brian. Who can round? Can you round this to the nearest hundredth? That means 2 decimal places. Round this to the 2 decimal places. You want to give it to someone else to get you some help? All right, quiet raised hand. Brian is going to call on you. 14.98, yeah, this is the decimal that gets rounded, so this is going to go up to 14.98, which means x is equal to 14.98, box it. That's the wrong box. I'll just do it handwritten, because otherwise it'll take too long. All right, let's do example 3. You guys are helping me more because you've seen an example problem. First, what trig function are we going to be using? We'll open this up to everyone now. Which trig function are we going to be using? Only one person knows. I'm going to wait until I get more hands. Which trig function are we going to be using? It's the same angle of reference. I need at least 4 hands before I move on. I see 2, 3, 4. Caroline. It is cosine because this is the adjacent angle, or this is the adjacent side length, adjacent to the angle, adjacent over hypotenuse, A over H, that's ka of SOHCAHTOA. So that's cosine of the angle, cosine of 32. Thank you, Caroline. That's going over here. All right, what's my fraction? Anyone can answer this. What's my fraction? I'm going to give Brian precedence if he wants to answer it first, though. What's my fraction? Beverly. It is x over 10. It is the adjacent over the hypotenuse. Thank you, Beverly. All right, from there, I don't need to get x out of the bottom. I don't need to switch those diagonals. From here, I can just multiply both sides by what to move what? I need to get x by itself. What am I going to do to both sides to isolate x? Colby. Multiply by 10 on both sides. If I multiply by 10 on this side, multiply by 10 on this side, the balance is preserved. Those 10s cancel each other out. I'm just left with x, which is equal to 10 times cosine of 32. Thank you, Colby. All right, from there, I pull out my handy-dandy calculator, and I say 10 times cosine of 32. 32 cosine. Cosine of 32 is 0.848, and I hit equals to multiply by 10, which is really just moving the decimal, and I get x is equal to this 8.48. I should have asked for a volunteer for the rounding, but that's okay. 8.48. and box it. And our final example. We get out of here at 9:17, which means we have 10 minutes left of class. Find the length of BC. I'm not even going to ask the first question. You need to ask that first question to yourself and answer it. What is my first step that I'm going to be doing on example 4? One person knows. 2 people know. 3 people know. I'm going to wait for 5 hands. 3 people. 4 people know. 5 people know. Chewy. It is indeed tangent of the angle tangent of 70. Thank you, Chewy. Who can do the fraction? I asked the question. I jumped too fast. Who can do the fraction? Only 3 people. 4 people. 5 people. I'm going to wait for one more. One more. 6 people. I need 6 people. There it is, Cheyenne.
9.
It is indeed 9 over x. Thank you, Cheyenne. Because the angle of reference is on the top, it's going to be opposite over adjacent. 9 over x. All right, what is my next step? X is on the bottom. Uh-oh, I'm going to have to use a trick because I need x on the top. What is my next step? Oh, there's some hands. Martine. Yeah, you can make this over 1, switch the diagonals. So read the new problem to me, Martine. 9 over tangent of 70. There it is. And then the 1 just kind of goes away. So x is equal to this. Thank you, Martine. All right, and then I need to do this on my calculator. So I pull out my calculator and I say 9 divided by 70, and then take the tangent of that. Tan of 70 is 2.7. I hit equals to do 9 divided by that, and I get 3 point what? Rounded correctly. I need one final volunteer to round this correctly. I see 1 hand, 2 hands, 3 hands, 4 hands, 5 hands, 6 hands. Caroline. 3.28. X, and I guess whenever we approximate, it should be this squiggly. X is equal to 3.28. This is being pedantic, but that's what we do in mathematics. We're often pedantic. You do this squiggly to say we are now approximating at 3.28, and I have now solved for x. Are there any questions on today's lesson? All right, that concludes today's lesson. Go ahead and write your summaries now. As soon as you finish the summary, you can begin on the homework either on Khan Academy or on paper.